Sorry, there's 60 seconds left. Do you think? Well, it's nice to see so many people here. I'm impressed there's so many FileMaker developers who make so many errors. You clearly should be more careful and trying harder. I'm Jon Jeffery. This is Jan. We have little slides later to show who we are, but we're talking about how to handle errors in FileMaker systems. Jan, do you want to do the next bit?
Yes. So very shortly, we're going to introduce ourselves, and we're going to talk generally about what error handling is, what the concept actually means, and we're going to look at some FileMaker implementations, namely errors as a result. When you pass errors as a result, you kind of bubble up, and then our exception emulation. And we're going to see whether we can bring those two together and make the best of both worlds. This is me, very shortly. I was born in Prague, live in Belgium for quite some time. I have a SQL Server background, and yeah, I worked 10 years for ClickWorks already. My hobbies, fast-pitch softball, popular physics. Meaning I like the discoveries. I have absolutely no clue what the math behind this is.
I'm going to hurry because I think we may run over time, but this is me. I'm a British guy. My background's in paleontology, which does lead on to computing in strange ways. My main hobby is still paleontology, but I collect Roman Republican coins, and it was my birthday yesterday, so most of you... Thank you very much. Most of you have probably seen these coins, but I have these with you if anyone was really interested in Roman Republican silverware. I'm happy to show you and talk about why they're so exciting, but we need to crack on because time is limited.
Yes. So,
what is error handling? Tell me.
Indeed. Might sound obvious, but is it really? Here's a definition that we both kind of like. Error handling refers to the response and recovery procedures from error conditions present in a software application. Okay, well, definition is nice. In other words, it means it is the process of anticipation, and that's really important one. Detection and resolution of application errors, programming errors, or communication errors. Okay. Let's have a look. What ideal characteristics do we want from a solid error handling engine? First of all, we want a unified way of ending the execution in case it cannot continue, right? We don't want one developer using one way, the other one in something different in one project. Right?
Graceful termination of the code. So when it quits, it does it in a nice way. It tidies up after itself. It doesn't leave anything hanging any windows anywhere. And again, a straight crash. Yes, a straight halt. And raises a good user experience that the user, whatever level they're at, needs to have some sort of message to tell them that it's not worked properly, and they should really end up where they started.
There are also two aspects of error handling problematic. Okay? First of all, when do you rise or create an error? Right? Second of all, how you respond to that, because these two can be separate. Someone makes a code that rises an error, someone else needs to use the code, and they need to then capture that error and react to it. Right? So clearly, you want to create an error when you get to a situation that your code cannot continue. Okay? You're stuck. In that case, you want to create an error when there is no business logic response as well.
So it can be handled differently depending on how you're interfacing with the interaction and in different areas. I would say the code here, just as an example, would be something like disk is full if you're trying to do an export, that your code doesn't have any, may not have any way of responding, that I was told to export this file. I can't export this file because the disk is full. What do you do now? There's no business logic to cope with that, so you have to raise it as an error and handle it as an error.
Another example here would be you have UI with user input, right? In that case, when the users input some crap, you usually don't want to deal with it as an error. It's a solid business logic. You just need to present them with the information, hey, you provided something wrong. The same thing when you have an API access point code, right? people call your API access point, you just validate the input and you give them back a message if things go wrong. But in both cases, you might have a core functionality behind these. And when this core functionality receives data that is incomplete, that should be treated as an error, right? Because you don't know whether you are in UI, you don't know whether you are in API call. You cannot go on here if your input is incomplete, right? In most cases, important thing, it's a judgment call. You can still see, yeah, I can deal with this as a business logic. I can deal with this as an error. But really, again, important note, this is the most common issue that we see across the code. People do not anticipate enough. They just code in the happy flow, and they never think of what happens if this fails. What happens if it does?
The happy flow. He did call
Yeah,
it the happy
I
flow.
did call it the happy
a lovely phrase, and it sounds a little bit rude.
I have to credit Joris for this term.
Very nice.
All right. Responding to errors. All right. If you are writing a code that uses some other functions that can potentially bring up errors, always handle them. Don't just ignore them. Don't think, yes, something will happen. You might have a top-level generic error handler in your application that just covers all your situations. Fine, that could be good. You might even have an explicit one.
To deal with special circumstances in that particular bit of script.
Okay. Log the error. Whenever an error happens, make sure there's a record for you to find back what happened. Very simple. And then notify the one who started actually the execution. Is it a user through their input? Is it an API client that made a call? You always have to tell them, hey, I didn't
do what you asked me to.
Right. And then if you have a proper error handler, you can actually decide, okay, I need to stop, I can't go on. Or you might have situations where you can continue. And then when you decide to stop, you need to do it gracefully. You can't have the user hanging in a situation that they don't understand.
Yeah. Going to another layout, open windows, all that kind of thing.
So I'm going to give now word to my colleague John.
So this is one implementation we did for large systems we called Bubble Up. So it's designed to be quite simple, quite lightweight, quite easy to implement so that people can do it in their own way. And the idea is basically every single script you write is kind of like a standalone thing. It tidies up after itself. There's nothing it does that it doesn't make sure it tidies up afterwards. It also manages any errors it has in its own right. So it's like having an explicit error handler for each individual script. And importantly, it always exits at the same point. There's only one exit point for the scripts. You don't have any halts or exit scripts in the middle. It always exits in just one place. And it always has a predictable output, whether there's been an error or whether there's not been an error. It's always the same bit of JSON is coming out in our case. Also in subscripts, because it's always exiting with this JSON, it's effectively passing the error up to the calling script. In case the calling script also needs to handle any errors at its ends to say, I called this subscript and asked it to do something, it hasn't done that, therefore I can't carry on either, therefore I've got to clean up my own mess. So it's like a sort of hierarchical system. The key behind it is this kind of standard script. It's standard in the way it's written. You always have this initialized block here where you write what it does and you get your script parameters. But the important thing here is you initialize this little JSON object, which in our case, it just has a little bit of information about the script environment. For example, who's running it, their privilege set, the time. It starts off with error. There's no error codes at the moment, so they're all just set to default of 0. And yeah, what the parameters I received are. It gives you basically enough information if you're trying to debug, you know what the starting conditions were. The next is the action block where you're doing the meat and potatoes of your script. And we always have this in a one-pass loop. I'm sure most of you have come across the one-pass loop before. So the idea is, if you haven't, if you try doing something and you have an error, what you can do is just exit the loop. And the beauty of this is, of course, when you exit the loop, you stop trying to do anything else and you go straight to the next block. which is the real advantage. If you have any data to return in your result, there is a little data key in this JSON we initialize, so you add it here, and you can add it as an array, as a JSON object, just as a single field, depending on what your script is doing. But yeah, if you need to exit with data, you do it inside that object JSON. Then you go to the tidy up block, and this is where the script basically resets any globals it's set, it closes any temporary windows, it does anything else there, and it may then have special ones it does on error, so that if it's creating a record, it knows that if there's been an error, I make sure I've reverted or deleted any records. So it's it's tidying up in normal circumstances and tidying up if it's encountered an error. And then finally, the exit block, which you can have a dialogue, which you may have a dialogue anyway. You may have a dialogue only if there's an error. You may not have a dialogue if you think it's going to be a not attended script, it's not a user interface script. And then you always, that's it, exit with the script result. So the very last step is always exiting with the script result. So whatever called this will end up with this information. And in this case, the script ran perfectly well, so there are no errors. So if you do have an error, say you try to do something and you do get last error, and this has a non-zero value. In the absolute simplest, you can just say, well, if the error isn't zero, I go in here and I update my JSON and I put the error numbers in the JSON. And now with these new the FileMaker script steps that came out in 19.6, where you can get the error location and the error step, and you can give much more detailed information. You can even have something, we've got a very nicely packaged custom function which automatically checks the error and can either deliver a custom message if you want, and it can also tell it there are certain codes that are okay. So say in this case I was doing a find, that it's okay for me not to find any records because I was doing a tidy up or something. So I can tell it any code that isn't a 401 is a problem, but a 401 is fine. And if you do have a message, give this custom message. So you can package it any way you want. Oh, sorry. I can say there's a demo file with this kind of code in it. But of course, at this point, you will exit the loop and you will go down to your exit, and that's where it triggers here. The handy thing about doing it in that format is, of course, it's very then easy to make a custom function that gives you a very standard error message. Because rather than every developer writing their own little error messages, you can say, no, you use this custom function and you give it the error JSON, the script result JSON, and it goes through it and it says, the person using it is a full access user, therefore I'm going to give them some quite detailed information, or it's a production environment being used by an ordinary user, so I'm going to give them a nicer message with maybe just the error code or a number that they can pass on to the tech team to do debugging. So it makes it much easier to have a very standardized experience across all your scripts. And then, of course, you exit, but of course now you're exiting with detailed information about why the script failed. Running subscripts, so here we're running a subscript, and of course you know when you're running the subscript what you're going to get back is that JSON. So the first thing you can do is get it from the script result. You know it's going to look something like this. If it's going well and there's no errors, you can then maybe look at the data block and say, I wanted to extract this data, so I can look at the data block, that out there. If there has been an error, you can simply look at this bit of JSON and say, there's been an error. What's important now is this script throws out its own script result JSON and it takes this on board. This is now its script result. So this is what I'm going to pass through. This is what I'm going to pass out the other end. So then I skip to my tidy up block where I'm saying, I do have an error, so I need to tidy up after myself. I know the subscript has done its own tidy up. I need to do my tidy up because I've had an error. And then I need to exit. I can give you a nice dialog box to say there's been an error. And then I can hand my script result back up. So you can have, as I'm sure we all have in our big solutions, a series of library scripts that do things like open windows and adjust windows and various day-to-day tasks that are sort of application-wide, but also some specific business scripts that do things like, I don't know, producing invoices and stuff like that. And it's very, very easy just to chop them all together because you know how they're going to respond. So if this calling script here, say this is producing an invoice, and it will get down to this point and it fires off a subscript, and at this point in the subscript, it has its own script result object, and that fires to here, where it then does this subscript, and this subscript again has its own error, and when it's finished, it passes that back up to script 1, which says, oh, it's all good, and that passes its result up to the main script, and things proceed in that way. It's like a sort of like a ball being passed up and down the chain, and at every point you know exactly how it's been going on, and then when you get to the end, you know that everything worked perfectly, and you know all your subscripts ran perfectly. Say if there was an error in the same circumstance, same thing happens, and we get here, and we have maybe, I think it's a record locking I did. Yeah, so you suddenly have a commit error. This one then immediately halts, goes to its own tidy up block, it cleans up after itself and exits, and it hands this error back. This script now takes that result as being its result and says, oh my God, I've got an error as well, so it tidies up after itself. It hands it back to the calling script to say, library script 2 had an error, there was a commit error, so this script then skips all the way down to its tidy up block because it exits the loop, goes down to the tidy up block, and it exits there, and you can either present that message to the user, or you can log it, or return the API result, or whatever, however you're doing it. The beauty is, if 2 years later, another developer suddenly decides they want to change the business logic a bit and add another few scripts, if they're all written in this way, they just plug in seamlessly. Because, the whole thing just works again. And if there's an error somewhere else, it's passing through like this, and there's suddenly an error here, it all just works. So as long as your developers are all writing the scripts more or less the same way, and you know it's going to give out this JSON that told you what went on, you don't have to worry about someone else plugging another script into your logic. It's relatively easy to the new transaction. Yep. Yeah. The calling script, yeah. Library 2, I'm assuming you... Pardon? Oh, sorry, repeat. Sorry, they can't hear you because of the microphone. To say, the guy asked, yes, there is an issue here where it will tell you that library script 2 failed. You won't necessarily know that it was which script started it. That is a flaw with this, but it's usually, I suppose, if in process of error reporting, the user will say, I tried pushing this button, and it went wrong. And I got an error saying, library script 2 didn't run. So it's kind of assuming that you are not totally coming in this blind and someone has told you something isn't working and you can respond. But yes, it is a shortcoming which the next half, watch this space. Transactions, it's relatively easy to link this into transactions. There's an excellent ClickWorks blog post written by me and my colleague Bert back there about how to use these new functions in transactions and get nice, consistent error reporting, which is not intuitive in all cases. You have to slightly adjust things. As you know, has anyone used transactions? Everyone used transactions? You played around with them? Yeah. One of the things there, you can explicitly tell it to revert, but there are certain actions that just cause it to revert automatically and you have no say in the matter. So record locking is a particular example. If there's a record lock, it will revert straight away, and that effectively halts the script. So it never has a chance to skip down to this to your tidy up block. So the problem is, it goes to the calling script, or to the point where the transaction started, which might be in a calling script up somewhere up top. And this is a subscript or a subscript, and the transaction fails there. You don't have this nice hierarchical tidy up block. It just gets sent straight to the end of the transaction block. So you can have a trouble with tidy up, particularly a transaction obviously itself reverts most things that happen, like record creation and those kinds of things are handled by the transaction. There are just one or two things that aren't, and particularly its global fields are not changed. It's going to layout, you won't be returned to where you are, and any temporary windows that you opened stay open. There are ways of handling that. Again, we'll cause that, but it is a problem. And mostly I found it's relatively easy to write my code, so that's not an issue.
Wonderful question about the error information that you get
Yeah.
after that situation, if I've seen correctly. Reports that the error occurred in the in the commit.
Yes, I have a demo file which is linked to this talk. I will show you how I handle it, but basically it's different from when you auto-revert from when you explicitly tell it to revert. You get different sets of information, and you have to slightly write your custom function to say, okay, this was an auto-revert, therefore I look here for the information, or it was a requested revert, look here for the information, compile it, and give. So it will still come out and tell you. And actually, I've got a nice demo that does, it's the same scripts, and one is run under a transactional wrapper, and one isn't. And in both cases, they give you exactly the same information when they fail, just to demonstrate it can be done. It's not very difficult. So similarly, it's a very lightweight approach, really. We're not doing anything too technical. I'm sure you've all managed to technically follow what's going on. The good thing is if you have multi-developer systems, so a big system that has many people working in a team, or a system that's being tinkered with over the years, and different people are looking at it at different times, it just gives a good way of keeping consistency. And one of the things is, you can be confident if you need to change something, any subscripts at all, you want to do the library script of open window, that will return you a decent error if you've given it an incorrect layout name or something like that. And you know that those subscripts will tidy up after themselves in a nice predictable way. The downside is, of course, it does rely on your developers coding in that standard script format. That's what they've got to do. If they don't, it won't work. However, it is fairly easy to explain. It's not rocket science. It's just a matter of initializing that JSON and really making sure you return with that JSON at the very minimum. And it's relatively easy to retrofit because all you do is take an existing script that isn't written like that, put a one-pass loop around it, initialize the variable and exit with the variable, and you've pretty much converted your script. It's very, very easy. I'm now going to pass back to Jan and hope you've got about half an hour to do your thing.
Very nice, John. Really, really nice and robust. Good. When I started to work for ClickWorks, right, I didn't know about the one-pass loop. It was like loop, you go through. Huh? So that's a nice feature. And I often ended up seeing halt, just halt. Huh? If things go wrong, people say halt. I didn't like that. So I started to think about ways how we could improve that and bring ourselves closer to what exceptions are. Let me just get generically to what I understand by exceptions. We have found multiple definitions, some even contradicting itself. So we said, for the purpose of our presentation, we're going to use this. An exception is when the control flow is disrupted by an exceptional event and the control is transferred to predefined code location designed to respond, right? So exactly not a bubble up, but out of control flow handling, right? This type of handling usually happens in the following sequence. The error information is created somehow. You gather all your information about the error, the application situation, and you haven't, would like to call it error object, but simply piece of data. Then the control is transferred to the error handler, and that error handler has access only to the information that was passed to it. That's the most common way exception handling is dealt with. Often you will see the try, catch, finally construct. It is often taken for an object-oriented language concept, but it is not exclusively, right? You can have try, catch in other languages, and it works perfect. When there is object-oriented language, usually the data is passed in an exception object, and there you retrieve all the values you need. Another example is Visual Basic 6 or pre, I think, like that. This was, in fact, an exception handling. You could say on error go to label, and your code jumped to your error handler when an error happened. So this, even though it didn't look like that, that was a solid exception handling case. So let me just go quickly through a graph. I like graphs. They are much more visual. And I'm going to go with the happy flow first. So we do a try block. We define a try block. We have some code, and there's a situation where we predict, we anticipate things might go wrong. Did they go wrong? No. Our code continues, and it jumps to the finally section, right? That's a section defined as a third part of the construct. There might be some cleanup, tidy up, as John says. Then the interpreter of your language looks, is there an exception still? Or is it handled? If yes, then we can go on. If things did go wrong, is this the sad flow? That's the sad flow, yeah. Ah, good term, John. Thank you. You throw an exception, create an error. What happens? The control is transferred to the catch block, right? There you try to do whatever you can to deal with the situation. Often you cannot. You just know things happen. I couldn't do anything with it. And then it again jumps to your finally section. Clean up. And if you did not handle your exception here, or if you did handle it, the execution continue. But if you did not handle it, a higher level error handler is called. And that's how you can nest error handlers in a nice way. What are the pros and cons? First, this allows you a clean business logic implementation. When you write your business code, you're not bothered by any error handling code in between your business logic. You can just nicely separate it. Whenever you have a business code, you have a guarantee of anything that was written before actually successfully being executed. In the case of bubble up or errors as results, you don't know whether a developer might have forgotten to handle a possible return value, okay? So exceptions are a safe way. If your code runs, you know everything before succeeded. But debugging is very unintuitive, right? When you debug through an exception, for instance, I did some PHP debugging. When an exception happens, suddenly you're thrown to a completely new debugging thread. All your control flow is cut, and all you have there is only the exception data. And if you didn't collect enough data, you're really lost. And it is very difficult to determine how an error will be handled just from looking at your code. You just don't know what is going to happen. Okay? Well, so we went through all the generic stuff. If you have questions, you can raise your hands, but I see I'm very clear. Good. Back to what we did in FileMaker, right? Obviously, we cannot have transfer of control. We can't, right? That cannot happen, but we can try to simulate it. First of all, when our developers encounter a situation where they cannot go on, they call this function. It's one simple function, error.new, accepts two parameters, number and a description that can be a JSON value as well. So we make it possible for anyone to put as much information into the error as possible. And the error exists in the form of global variable, right? Create $_error using a custom function.
There's only $1 there. No, that's just there. So he only wants to use the custom function, and you have to do.
Oh, don't look at the code. Just
No. Okay. Okay, sorry. If for anyone that doesn't understand what's going on here, I'm not assigning any result of my call to a variable. I'm just using the calculation engine, and inside of the error.new, there's a let statement that creates the global variable. We're using this concept actually a lot. Misusing calculation engine of various script steps. Yeah, Joris?
It's a wrapper, basically.
Yes.
Just a function around the global variable.
Yeah. Fiori says it's actually a wrapper that allows you to control global variables using custom functions. Of course, we have more functions. We don't have just this one. We have wrappers of wrappers, as you can see. So this function will simply look, is there any result to get last error? And if there is, it calls the first one with the get last error number as the first parameter. Here again, this message that you can pass in. That's a sample of what we do right now as the error data. First, security information. Many errors are caused by security. So it's really always good to know who was logged in and what happened there. You see, I used error 401, no records found. We have the description is actually, it comes from a separate table where we have table of error codes and error descriptions. All the FileMaker errors are in there. And we have here the location and detail that was empty. If you want more details, you can always talk to me after that. But that's not all. If you just create a global variable, you still haven't done all there needs to be. Developers, when they want to create an error, they need to call this script, right? And that's all we require of our developers when they anticipate an error. Create error using a custom function, call this script. And of course, as I have explained, we do it in one step. We abuse the perform script calculation engine to create that error, and the control is then passed to our error check script. What does this error check script do? In this basic scenario, it does only one thing. It calls our default error handler, right? And that's where all the magic happens. First of all, we create a log entry in our log table. We send an email to project support address if defined. It's a project configurations thing. If we are in an interactive environment, okay, FileMaker Pro, FileMaker Go, FileMaker Web Direct, which have I omitted? Sorry? Server. That's not in interactive environment. Studio. Is it an interactive? No. I'm going to relieve you. It's the runtime, which is deprecated already. These are the four environments where FileMaker can receive input from users. Then we show a dialog with the error, right? And here is one very important thing. In that dialog, if the privilege set is full access, we put a debug button there. So if a developer sees this dialog, they hit debug, the dialog disappears, and we put the script on indefinite pause. So anyone can then open their debugger, in the call stack, navigate to the place that actually created that error, and immediately check what the variables were, what layout they were on. Joris? Do you have a picture of that? Unfortunately, I don't have a picture yet, but it
is very handy that as a developer, what you're seeing is runs an error, you get a thing saying, oh, there's been this error, do you want to debug? And then you can step back out of this error handler script, back to where the error initially occurred, and go from there.
Bo? Probably not, because that's one thing. We have been testing this just a few weeks ago, and our Windows users complain that they're actually not being paused in there. That's true. Yeah. And we agreed we would investigate. We didn't get down to it. Yeah, unfortunately, we're mostly. Yeah. Okay. Well, nevertheless, so this is a very handy feature on Macs. And then we close all internal windows. Internal windows, for those who are not familiar, are windows that are actually opened outside of the screen to allow out-of-context operations. We do that very often. Well, temporary, yeah, they are temporary. I like to call them internal because reasons. And we have a naming convention that allows us to identify which they are. Right? So we close all of them, and we do revert in all of them before closing. Just, it's an attempt, right? It's not guaranteed, but so far it always did better than if we just left things as they were. And here comes the critical thing that many people say, oh no, you can't do that. It executes a halt, right? But it works. So let's go through some of the, yeah. Well, actually, I have the sad flow right here. Huh? So something goes wrong. We create the error using our custom function, and we perform the script. Okay? The script checks, again, do I have an error? That actually allows us to just put calls to that script wherever we want to without if statement wrapped around the script. We just put that check in here. If there is an error, indeed there is, we call the default error handler, we revert all we can, and we halt. So the user is almost always, and the developer as well, always in the situation they were in where the script started, right? In fact, users should almost never be, should never encounter this. These are things we need to find and discover before we go to production. Yes? It does, because even that custom function, if you use that get last error, it checks, is there a last error? And if there is no, it will create no error. So this script then will see there is no error. So we really like, in many places, we just, sorry, okay, we stick actually this in many places, just, and not exactly this, we use this custom function in here. Sorry, I have chosen the wrong example, but in many places of the code, I just stick call to the script with this, and if the get last error in this case gives me a result, I'm in the error handling flow. If it doesn't give anything,
Straight back out.
the script just picks up, as you have seen, as it would do here. Right? Okay, we revert all you can. No.
Yes, you don't have to, but yes, in practice, we always do. In practice, we always do because it's so simple and it actually has no impact on performance that's noticeable. Because it's quickly jumping into a subscript saying, oh, there's an error, back out again.
No.
Yeah.
Maybe to clarify, this is already inside that script.
I think it's the other bit. I think it's sorry. It's this bit is saying it never does because we say we always actually run the script.
Oh, but there might be different. I mean, here you are in the top level business script, right? You might have some kind of I don't know, whatever happens, anything that happens here, and you validate that as an error condition, right? So that happens quite often, I guess. You do execute open URL.
I mean, you might have a situation where it generates an error and you want to try something else, and you want to try maybe something else, and then you say, right, okay, my business logic's tried all the three options. Now I'm going to throw it.
Yes. Yes. Sorry, my apologies then. Yeah. Yeah. What Yuri said is that the first condition is kind of misleading, confusing. Yeah, well, 20 minutes, right. We have added process tracking to this, what that is, okay? Whenever a script starts, we create a global variable process, all right? This is, in our environment, fully optional. Now, it brings many advantages. I would never choose not to do that, but there are developers who don't want to do that, so all that I'm demonstrating works without that. Our process is managed via custom functions, as always, right? And this is what we do at the start of every script. A call to a function, period. Nothing more, nothing less. That generates this JSON object and puts it into the process global variable. First of all, we have a call stack. Because every script does that, we know what the call stack was in case an error happens. So when there is an error, we just take the call stack, put it automatically to the error information, and then whenever someone looks at the error log, they see, okay, this, and this script were in the call stack when that happened. Second, state snapshot. All the information FileMaker gives us about the state of the file, what windows were open, what is the position of current window, what is the zoom, whatever, we just stack it in. Okay, why we do that? Yeah, oh, sorry, I'm gonna get back to it. And then this injects a local variable, right? The function call. Why does it do that? So that this function knows it needs to clean up the process object in case this variable is true. So every subscript will just know, right, the process exists. I'm not going to tell my onExit to clean up, but if it is instructed, the onExit function will clean up. It requires discipline from the developers. They need to always use this function before they exit their script.
What was the function that created the
Script on perform creates the global object.
global variable, but that's in every subscript. So
Yes.
the first one somehow recognizes
Because
it's the start.
This
Because dollar
doesn't exist.
doesn't exist.
Doesn't exist.
But
Joris?
didn't you just show a error handler which does a halt? The error handler that does a halt
Yes.
also needs to clean up.
Yes, I forgot to say that it cleans up the project indeed, process indeed. But that's only when you use the process. You don't have to use it. So that's why in the first...
So long as your script logic does get rid of dollar process.
It does, always. It does. Joris? Yeah.
No, but what I'm saying is one of the bugs that you might have is you've forgotten to do the exit script, so you forget to clean up your process. So your next process, which has decided not to
Right.
use this,
I'm going to stop you. I'm going to stop you. When we did our dry run, we got to about 1 hour and 20 minutes. So let's try to get through it, and maybe there is time for Q&A. So yeah, this happens, all right? And this, as you can imagine, allows us much more precise revert in case things go wrong, right? Discipline. It requires discipline, right? So we really know everything that the state application was in before the script started, and we can delete all the windows that were open. We can navigate back to the layout where you were. Yeah.
So it might be easier if Jan gives you a demo after the talk.
Yeah.
So just take it on faith it does work. And we give you a detailed demo.
Yeah. Of course, this might not be enough. So we have added custom error handlers. Our developers can add custom error handlers. They are designed to fix specific issues that they can fix, because the default error handler doesn't need to fix anything. And again, they're activated via a custom function. So whenever you're in your code, you anticipate that your subscripts or whatever can create a certain error, and you know how to respond to that error. You call this custom function, and you give it as a parameter the FileMaker ID of the script that should execute if there is an error. Very simple. You may not forget to deactivate once you reach to the point that you don't need it anymore, right? As you can imagine, this is fully stackable, so you can have a hierarchical error handling structure. And what it does, it adds to the process variable this array. Okay? So when an error happens, we know we have to call this script. If the error has not been cleaned, we call this script. If the error has not been cleared, we call our default error handler. But still, we have only two possible outcomes. We either can continue after the error check script step, or call script step, or we can hold, nothing more, nothing less. And yeah, for that, we don't have the time. Sorry, we don't have. I wanted to explain what the use cases are, but maybe we can talk about this. I think the logic here is enough. So let's just go quickly through that. If you have a script there where something goes wrong, you call our check. Okay, is there an error? Yes, there is. Do we have a custom error handler? Yes, we do. Let the custom error handler do its stuff. Is the error cleared? Yes, it is. We exit script, right? Oh no, we didn't clear that error. Yeah. Is there a custom error? Oh no, not anymore. We end up in our default error handler, revert, halt. Joris. Yeah, that's most common. What Joris is saying that in most of the cases we end up in the default error handler anyway because the custom error handlers are not used that often. So let's sum up what we talked about. We have a unified way of handling errors, right? The developers use a custom function to create errors, and then they instruct our error engine to deal with that error by a call to a script, all right? Sorry, that was too fast. We have the ability to design custom error handlers that plug into the system. We have the ability to precisely revert whatever happens during the course of your script run. We call it a process. And we have a very important ability to open the debugger wherever the error happens. So you don't actually have to go and debug your scripts if you know they go wrong. You just hit it, you wait for the error dialog to pop up, and you go to your debugger. If you're on Mac. If you're on Mac, yeah. So, of course, John's, sorry.
Are you always in a card window? If you're not in a card window, you can
Yeah. John's amazing presentation has brought us to the possibility of merging these two. So,
we had fights about this.
yeah, always. Huh? What's the plan? We don't have that yet, all right? It's a concept. We want to keep the error handler really where it is now. We love the debug button, okay? So we're not gonna move the handling to some other scripts. And what we want is for our custom error handlers to tidy up in the section where they are active and then continue the execution on, right? Like a typical try-catch would do. What do we need to do for that? We need this function call that activates a custom error handler to actually take the snapshot of the application, the one that our process started us right now, if you remember. Yeah? So right now you have seen the array where every item was just a reference to the error handler. This will be in the future, if we agree to go on with that, one item in that array. It will still be the name of the server of the script to execute, but we will attach the whole snapshot to that, right? And then whenever anyone designs an custom error handler, they get the opportunity to call restore state, and we will revert only what has happened since the deactivation of that error handler. Right? Because we know what the state was. Huh? We have actually copies of the states as the custom error handlers were activated. So we know what to revert. And then the custom error handler will instruct the error engine to jump out. Right? We're still now we're in the bubble up scenario where the developers have to provide the means for bubbling up. Okay, we can't do that automatically, but we have already the engine being instructed to do so. Right? So let me just present an example. I hate to throw scripts into presentations, but here it really I can't go any other way. We want to make a script that sends email messages, one email message, right? You have a message record, and based on that, you want to send an email. Yeah, a script responsible for sending a message. This script can be used in two different scenarios. You have an editor in your user interface where users create emails. They hit the send email button. In that case, stopping is perfectly fine. Huh? You can say, okay, I can't go on here, fine. But if you have the same functionality in a server schedule, when you have like heaps of messages to send, one message that would, in our current error handler, cause the whole process to stop would completely block the rest of the queue. And we don't want that, right? So let's see how we would go about doing that with the new ideas for combined error handling. We're going to have a script that sends a message and it generates these through errors. 20,401 if the authentication to the external system fails, 402 if creating the message fails, 403 if sending fails. All right? We start a script that always initializes the process. We try to authenticate. If it fails, we call error check with 20,401. Then we go to create that message in the external system. Again, if we fail, we raise the error for 20,402, and again we instruct and we go on. I'm actually rushing through, but you can see that we always have there the exit loop if, process jumping out. That's the engine telling us you have to jump out. Because here, inside of that call, the custom error handler written for this would instruct the system to jump out, right? Yeah? So this script knows I cannot continue, I have to bubble up, right? So, and again, three scenarios, and now once we're finished, we probably would mark the message as being sent or whatever. Exit loop if true, you always need to do that in one pass loop, and exit script with on script. This is how the loop, what the loop would like, right? Sorry, I'm a little bit lost. Custom error handler. Yeah, no, sorry, my apologies. This is what a custom error handler would look like. You get the error as a parameter, and then you just check, do I have any of these three errors? And if I do, I log the error using our standard script, and I say, jump out. And that's all that needs to be done. In all other cases, we haven't cleared the error, and our error engine continues probably to the default error handler, right? And now comes the schedule, okay? we start with a single pass loop, one pass loop. We loop now, we find all the messages, we loop over these messages, we activate the custom error handler. This loop actually is another single pass loop that substitutes the try block. It is the try block. We have activated the custom error handler, and now we provide a try block for it. So it calls this message sent. Do I have to jump out? Yeah, it could be if things went wrong. If not, I can continue. If I did jump out, I deactivate my custom error handler. If this custom error handler was instructing the engine to jump out, the function to deactivate would clear that information. So now our script would go on. In other cases, it would keep jumping out, right? And go to next record, exit loop, and we're there, right? So we made it, and we have still 5 minutes.
So, in subject.
So I think in summary, Jan's, as you can see, is a lot more technically complex and maybe harder for new developers to understand what's going on. The bubble up is really simple because it just uses quite regular FileMaker and very, very obvious FileMaker code, but lacks a certain sophistication in terms of tidying up particularly. So what you choose to implement just depends on your budget, the size of your project, what you feel comfortable with. But hopefully this kind of hybrid method we'll be working on will give you the ability to just use a simple one in smaller cases and maybe use the bigger debugger in bigger cases. Any questions?
Yeah.
Do you have a microphone?
No, we need to repeat the questions here.
Oh, God, okay. So he was saying, yes, it would be nice if, with my bubble up method, if I recorded the name of the script and added that to the JSON object as I exited. I will do that as soon as I leave this meeting. That is a very good idea. Yeah. What about JavaScript and plugins in the web viewer? I must admit I don't handle that at the moment. That's not part of.
Not out of the box, but you can always design your own detection method. And when you detect an issue, you call the standard error handler error check script, and you give it the information.
That's a question, not him. Put your hand down. Yeah, no, go for it.
Very nice. I've got a similar system. Error object back and a result object back, much like the same.
Yeah.
The only difference there is each of my error object can have an embedded error object. I don't know if it's a good idea. I don't know how useful it is, but it means that if some subscript or API produces an error, and this script doesn't really know what to do with it, I can just pack the detailed error inside a kind of like a general error, I can't do anything error, and then that's passed up, and then the user only gets to see the top level of error and then can unfold the rest.
Actually,
Probably would be easier as just an array of errors, so that you look at the first one and get the simple message, work, and then you can look down.
I would say my bubble up method evolved actually out of a project we did for the British Paralympics Association, and they wanted to have a website it was during COVID, where the athletes would be given kit, and normally they went to a big area where they could try on the different a tracksuit and a pair of shorts and stuff and make sure they fitted. But during COVID they couldn't do, and they had to be just sort of sent stuff like an online catalogue. And they had to have a website where they could say, this T-shirt's too small. Actually, I want this bigger pair of shoes, or this was damaged. But of course, it had to be completely accessible for people with vision impairments. And we were thought of doing it in Web Direct, but it just no way. For screen readers, you need to pretty much code it yourself to make it fully compatible with screen readers for people with various visual impairments. So we ended up with a ordinary written website using FileMaker for the back end, because the warehouse people who were doing all the picking and packing were using FileMaker Go to do all the stock control. So it had to interact with this FileMaker back end. And what we found, if we just use the data API to trigger various scripts, what we could then do is have our FileMaker people could write the scripts to do all the FileMaker stuff, and as long as it exited with this JSON object, we could then just hand that back as the API result, and my JavaScript knew what to do with it, because it was always getting a result we would understand. And if, you know, it's kind of 3 levels. If the data API failed to even get there, you'd have 1 error. If it got there, but for some reason it couldn't run the script because the script was missing, you got another error. And then inside the FileMaker, our developers returned this bit of JSON, and I could then finally look to say what happened in the script. And if there was an error, they would have written this custom message that was okay to display on the screen to the user to say, something's gone wrong, I'm afraid you can't return your trainers. But it did mean that we didn't have to get our FileMaker developers involved in writing something that was a bit JavaScripty. We could just tell them, look, initialize this JavaScript, this JSON object, make sure you spit it out at the end. And so even our juniors could be involved in this project, because it was obviously a bit of a rush. The Olympics happens in July. That's your delivery date. There is no option to change it. So it was really handy to have an external system calling FileMaker through the API. And it was a lovely way of just allowing FileMaker programmers to program FileMaker, and the JavaScript always knew it was getting something consistent out. And
Honza is here, so I think we need to clean up.
Sorry.
I just want to quickly pick up on your comment. I'm very strongly against bundling up errors together. If you have a situation where you cannot go on, you don't go on. If you can go on, it's not an error situation.
You can fight that out later.
Sorry. Thank you very much.